These are called covalent / molecular compounds. These are covalent / molecular compounds. And these are a 3 with a 3. Everything in group 3 is a what? What are these all up here?
Non-metals.
Nonmetals, yes. So these are 2 nonmetals. These are 2 nonmetals. 3 and a 3. And the difference between these is these share electrons. So everything we've been doing so far has been transfer of electrons, right? So these share electrons to get the full outer shell. To get the full outer shell. And how many is in a full outer shell? Usually 8. So you can put in parentheses 8. So everything we've been doing so far has been transfer. The metal's been given to the nonmetal. The cation's been given to the anion. Now we're going to be sharing. Cool? Okay. So the first thing we have to talk about are diatomic elements. So diatomic elements. The prefix di means what? 2. Yes. So these are elements that never exist as single atoms. Elements that never exist as single atoms. And you probably might be like, well, Mr. Heller, what do you mean by that? Here's what I mean by that. Here's chlorine. Has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7 dots. Has 7 dots. Let's draw another chlorine beside that. 1, 2, 3, 4, 5, 6, 7 dots. You would agree that that's Lewis dot structure for chlorine. See? If this chlorine would give an electron to that chlorine, would it want to do that? No. Why not, Ted? Because then instead of 7, it would be how many? 6. Does this chlorine want to... It wants to still get one, right? What these do is they share a pair of electrons. So now we're going to be circling the shared electrons. So for our ionic compounds, we drew an arrow, right? Now we're circling. So this one now has 1, 2, 3, 4, 5, 6, 7, 8, because the pair counts for both. This one has 1, 2, 3, 4, 5, 6, 7, 8. Both are happy. So this is Cl2, diatomic element. Diatomic element. What about oxygen? Oxygen has how many dots? 6. So oxygen has 1, 2, 3, 4, 5, 6. Here's another oxygen, 1, 2, 3, 4, 5, 6. Does either one want to give one away? No, right? Because if it gave one away, it'd only have 5, yes? So these need to share a pair of electrons here. Now what have I done to both of them? What did I do to them, though? I poked the bear. Thank you. Who said it? Thank you. I poked the bear because now they both have 7, right? So these are going to actually share 2 pairs of electrons. Those are going to share 2 pairs of electrons. So this would look like this. An oxygen double bonded to another oxygen. That is O2. That is oxygen gas that you breathe. You never just breathe O. You're always breathing oxygen double bonded to another oxygen. Cool?
But does it matter that the double bonded, that doesn't matter?
No. You breathe them just the same. Did you have a question, Clara?
Yeah, it's really
Well, if the first one, Cl2, why is oxygen? Because there's more.
It's still O2. There's only 2 oxygen molecules, right? So I've got 2 Cls, 2 Os. Cl2, O2.
Like, let's say oxygen was missing another one. Like,
It's not though.
but like, what if?
Okay, what if? What about nitrogen? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nitrogen's missing another one. Yes?
Yeah.
Guess how many pairs it's going to share? Going to share a pair here. Share a pair there. I don't know how I can draw that. Share a pair there. Nitrogen shares 3 pairs. There's not. There's not. The most you can ever have is a triple bond. So that's a nitrogen triple bonded to a nitrogen. So this is N2. If it was 4 and 4, that would be a perfect match. That's N2. So could you do something like this? If I had carbon and oxygen, right? Carbon has how many? 1, 2, 3, 4. Oxygen has 1, 2, 3, 4, 5, 6, right? Going to share a pair there. Share a pair there. What do I need another one of? Another what? Another oxygen, right? Get another oxygen here. 1, 2, 3, 4, 5, 6. Share a pair there. Share a pair there. So it's the same thing as what we were doing, except for now we're circling instead of drawing arrows. Guess what compound this is? Carbon dioxide, CO2. Where carbon double bonded to an oxygen, double bonded to an oxygen. What's that? Everyone's happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everyone's happy. So how do you name these things? Super easy. For the names, you just use prefixes. Use prefixes. Look at the back of your periodic table. You'll see a list of prefixes. Do you guys see where it says 1, mono, 2, di, 3, tri? Do you see that on the back? Yes? Here's the cool thing. We don't care about charges. If we don't care about charges, that means there's no crisscross. There's no crisscross. That means there's no reducing. It's super, super easy. There's no reducing. The one thing you have to know is that mono is only part of a last name. So you'll never have mono as part of a first name. And once again, last names, guess what they're going to end in? Last names end in IDE. Last names end in IDE. So these are super easy. You can see something like this. B4H2. So what is the prefix for the number 4 on the back of your periodic table? Tetra. So my first name is tetraboron. Tetraboron, right? Prefix for 2 is what? Di. So what's my last name going to be? Dihydride. Tetraboron dihydride. What about this? Can mono be a first name? So my first name on this one's just what? First name is what? Carbon. How many oxygens do I have? What's the prefix for 2? Dioxide. That's carbon dioxide. What about CO? This would be carbon mono or monoxide. Yes. This is.
Doesn't that stuff kill you?
Yes. Carbon monoxide. Neither of them are great to breathe, but carbon monoxide is especially bad. Okay. Could you write a formula for this? Hexasulfur pentaiodide. Write the formula for hexasulfur pentaiodide. It's super easy. Sulfur's S. Hexa is the prefix for what? 6. Iodide is what letter? I. Penta is the prefix for. That's it. That is it for these. It's super duper easy. And you don't reduce, because that would change the name. Perfect timing. Your homework tonight is the large page is doing the Lewis structures with the circling. The short page are the names and formulas. Together, these will probably take 7 minutes.
Nah.
It's super fast. Super fast. Very nice work today.